All right. Hey, guys and gals. Hey, guys and gals. What is good? What is good? How the beep are you doing? Let's go. Let's go. Turn it up. Turn it up. Turn up your turnips. Boys and girls, turn up your turnips. Turn it up. Let's go. Let's go. Yeah. Turn up them turnips. Much love for you lurkers and twerkers and sandwich making workers. Turn it up. Appreciate you stopping by, dropping by, supporting the content. Johnny here at Bologna&Weiners Coding. Let's go. Let's go. It's time for the show. It's awesome. It's awesome. Thank you guys and gals. You guys slowly finding the content, man. You guys are all legends. I'm telling you. Not capping. Besides, I don't lie in BS anyways. I like to be real, you know? Real. Anyways, not to go on a tangent, but it's great to have you guys and gals. Thank you for finding the channel. First off, it's great. Like I don't know how you're doing it, but it's amazing. I should realize you are beautiful, intelligent people, so I should know this. That's true. That's right. What am I thinking, Bob? Unbelievable. Yeah. Man, much love. And then hitting the follow button. Turn it up. Turn it up. Brother, thanks for the recent follow. Hood Rich. I know what's up. Let's go. Hood Rich, appreciate you. Let's go. Do I have to fix that? Some of you guys, I love you supporters. I truly do. It's wild. Some of you have really long names, so I'm trying to adjust for the long names. I can't fix it right now. I'll just do it later. Followers, supporters, you guys know how I feel about you. I've said it lots. Plenty enough times. Let me finish up with chat here so I could get those thoughts off my mind and focus a little more. Again, I'm my own mod here, so like, what do you guys think I am? An octopus? It's funny. It's so funny. Trying to keep the content PG because trust me, I'm not afraid of the usage of expletives. It's so much harder to contain yourself from, saying such things, such words. Appreciate you, guys and gals. It's great to have you. It truly is. It's great to have you. Thank you for the support. Whoever you are, dropping by. Consistent, lurking. Man, amazing individual. Whoever you are. I thank you. Like, seriously, thank you so much. Could be more. I don't know. OBS broken. It's not OBS, Streamlabs. If I had to stream up, I would know, but whatever. I'm just still rolling with it. I still go. Again, I get up, get knocked down, I get back up. That is I. Okay? Knock me down. I'm going to get up. Okay? For real, for real. All right, so yeah, I keep going for you guys. Those of you that are watching the content, again, it's you guys and gals that keep things going, right? There's days I just want to say, you know what I mean? Like, I just want to say, right? But I keep going for you guys, right? I'm also enjoying doing this. I don't mind doing this. It's kind of fun for me. Helping you guys learn and grow as well. That's kind of the goal here. Something positive, helping the world learn and grow. Doesn't matter where you're from. I don't care. Hope I'm helping you. So yeah. Did I finish the stuff in? Yeah, I was just I kind of threw out that joke, but I always say that to my kid whenever I have to go grab his dishes and stuff because, teenagers, they don't know how to put stuff back into the kitchen when you give them food. You drop piles of stuff on their table. Anyways, he's like, you forgot this? And I'm like, what do you think I am, an octopus? My hands are literally already full. I love my boy. He's awesome. Yeah. All right. Am I almost done? I am almost done. I must finish up with ye old chat. Dropping in. What? Jeez Louise. How do I do stuff like that sometimes? I don't even know. Just copying and pasting, as you guys figured that out. As much, right? Man, you expect me to type words without messing them up? I can spell, I just can't type. I'm the worst typer, gamer typer. I got gamer typer skill. I've done that. Let's do this. Let's finish up. Close. Don't save. Be gone. Thanks for being around still, WordPad. It is 2025 and I still have you with Windows 11. Joke's on you, Microsoft. It's awesome. Okay. All right, we're going to get going. It is Friday, right? It's Friday? Yesterday was kind of a nice sunny day. It was definitely a get outside and, actually see what the air looks like outside kind of day. Yeah, I did get out. Today a little bit gloomier, but it's Friday. Friday's a win, right? Friday's a W. Everybody loves Fridays. If you don't like Fridays, what's your dealio? Dealio? Or I should have said Delio Emilio. That would have been better, huh? Hey guys? Yeah, it would have been. Man, I almost pulled a George Costanza. I just figured I'd change it up. Okay. Do this. Quick shout outs. You guys, gals, much love, much love. I closed that. So, geez, amazing. I'm so amazing. Anyways, I'll try to do shout outs to you guys and gals next week. Recent follows, though, in the last couple of weeks. You guys are amazing. Thank you. Chama 117. A Music. John to the One, brother. Thank you for the raids. In the past. Appreciate you. Rough Riders Gaming. Let's go, brother. You're cool, man. You are cool. I love it. I love it. Keep hitting the follows, you cool people. Okay, Yeah. Low Level RS. So Snob. I don't know, bro. Figure it out. I like that. I Try Ty. How you doing, Ty? The Absent Present Person. I love that. It's so unique. And I love it. White and Hood Rich. Let's go. Turn it up. That's awesome. Appreciate it, brother. Appreciate you. You know it. Let's go, man. Thanks, guys. Thanks. I see that stuff and you guys put a smile on my face. Hits the old heartstrings too a little bit. I don't cry. Okay. Oh, it's close. It's close. Just jokes, guys. Just jokes. But yeah, it feels good. It definitely feels good when you do. All right, we're going to get to learning. All right, that's kind of what we're doing over here, right? Okay. This is a course/lecture, just to give you guys and gals a heads up, okay? All right. If you're looking for that 5-minute video on how to create a variable name, you haven't found it. Let's go. Yeah, course lecture. You are welcome to stay if you're checking it out for the first time. By all means, man, it's great to have you. It truly is. Thank you for learning along here. Right? It's great to know. It's good to know that people are like learning and wanting to learn this language. And I'm not just sitting here talking to myself. turnips. It is Friday, guys, okay? I'm allowed to chat with you a little bit before we get going. Right? Yes, I am. I do recommend, if you want to learn C++, okay? I know it's not for everybody, okay? Right? I do have a saying. Man, I closed my program. I have it in chat, don't I? I do. I can read chat. Where is it? When they say it's impossible for them, not for you. Let's go. So yeah, I have to export all my videos to YouTube. Unfortunate. I don't know how to take that to be honest. Because, YouTube seems like they're canceling. I don't know how that works over there. Not to go on a tangent, but like literally public view hours. I don't know if you guys know anything about public watch hours. As a small creator, you kind of pay attention to those numbers because you want to get to 3,000, right? You're kind of eager, and then all of a sudden you lose 150 watch hours over a period of a week or 2 weeks. They started using the minus. I don't know what's up. So anyways, it's great to be back on Twitch. It truly is. You guys are showing up. You truly are. You guys are different over here. I love it. I feel like this is home that I never should have left. And I feel like a donkey leaving years ago to move over to YouTube. And for what? To be ignored? Man, not everybody. There were some, there's slow growth, I guess, but I'm not giving those on YouTube and followers a hard time. You guys are the reals. But yeah, no, they dropped the ball over there. And you guys on Twitch, man, you guys have been showing up. You've been finding the content. You've been watching. You've been following, subscribing. Man, I'm strong inside, but man, you guys are making me feel soft inside. I love it. Thank you for the support. I want you to know, I go on and on and on about this, but like, man, how many people go on and on about saying that they appreciate you? So welcome, lurker and twerker, chatter. Appreciate you stopping by. Let's go. We're going to get into it. So yeah, I got to finish up. I kind of go on tangents a little bit. I do apologize. Eventually I'll get focused. But yeah, over on YouTube, there is a playlist. It was a course. Now it moved back to a playlist. Thanks, YouTube. Not sure what's up. They recommend a course outline and they just went, yoink. Nah, you can't have that. You're going back to a playlist. I don't know what's up with that either. So, but all my videos, my streams on Twitch, I export them over there because, well, I only have, a week for each video. So if you want to see the content on Twitch, you kind of only have a week, which is unfortunate. I'm not going to say anything bad about Twitch. Appreciate Twitch and the viewers and the supporters. So, but I am, thankful that I can save the live streams. It is a course outline I'm doing. So if you want to learn C++, the videos are all there. I'm thinking of changing the channel name to Bologna&Weiners Coding. I was really thinking about that. That's maybe the name coming up. That's right, that's right. Grinding 10, 12 hours days. Living off bologna and wieners. Let's go. Life is good. Life is good. Life is great. I got my kids, so I'm really happy. That's all that matters. So over on YouTube land, all the videos are there. Follow the series. That's what I recommend. Go step by step or gradually, you guys are gradually growing in regards to C++ with each video. We are going to do another pointers video. I think the last one I explained it really well. I hope it helped a lot. Yeah, I think I did. A lot of people can't get pointers. So I do my best to kind of make it easy and simple for you to understand. I do need to get going though. I do need to get going. It's great to have you. Again, this is a course / lecture that we're doing every stream. Appreciate you being here. Let's go. Yeah, let's get going. Enough's enough. It is time, boys and girls. It is time. It is time. Put on the old thinking cap. Flick the old switch in the brainium cranium. Let's go. Yeah, it's time to learn. Okay. So, Johnny, get focused. Right. The channel. Currently, it's WhiskeyTango coding, or WhiskeyTango sharp, I mean. I may change it to Bologna&Weiners coding, because Bologna&Weiners sharp doesn't really kind of fit. So, if you are looking for the channel, you should be able to find it. Same profile icon. That'll help you. All right, thank you, supporters, followers. Again, I appreciate you. Let's get going. Quick drink of coffee, and we're going to read the course outline. We're going to follow the course outline today. All right, guys and gals? That is what we are doing. Yeah. All right, turn it up. Turn it up. Okay, time to read. Let's do this. We're doing it now, boys and girls. We're doing it now. Getting a variable's memory address. All right, we're continuing with pointers. All right, understanding pointers. That's what we're doing. This is kind of well, it's going to be kind of a recap, I guess, but this is kind of little more reassurance, a little more theory and such for you guys and gals, okay? So the kind of little more reassurance, right? A little more reassurance for you. Again, I am following a course outline. I should, kind of follow it once in a while, I guess. Different computers number this memory using different complex schemes. Usually as a programmer, you don't need to know the particular address of any given variable because the compiler handles the details, right? Like I said yesterday, the RAM or the CPU, the RAM is the CPU's library. Okay, it's a temporary library. Once it gets closed, it kind of gets emptied. Real life, that's not a real life thing. Libraries always have books and information. But RAM is temporary. It kind of gets wiped, refreshed, cleaned. And that's kind of part of being a coder. You got to kind of manage the memory as well. You got to kind of be a housekeeper as well. So that's getting into heap allocation and dynamic memory. I have no problems doing housekeeping. Like, it's not even like what you type delete. Oh no, I have to type some more characters. Oh, the humanity. I quit. That's just a joke, guys and gals. Don't quit. Please don't quit. You can do this. I believe in you. You can do this. I try to support you as much as possible. I say it so much. Try to keep you motivated, keep you positive. Okay? There's gonna be days, you know, mistakes. I don't want, mistakes are gonna happen. Just accept it, right? Try to figure it out. Okay, if you need, go take a walk. Walk away from it. Come back to it after. Give it some time. Think about it. Let all the information get absorbed in, like a sponge. Okay? All right, let's continue. Again, you just got to keep pushing and grinding. You got to keep motivated. You got to keep yourself motivated, right? I can only hold your hand for so long. Sheesh. I say that with lots of love. I do, okay? I do. I care. I want you to be successful at this. I truly do. All right, here we go. Okay, Johnny. Get to the course outline. Stop going on and on and on. If you want this information, though, you can use the address of operator, right? I'll just kind of type it here. We've done some cleaning here, okay? And I'll just kind of copy and paste this again. They call it the address of operator. I had some different names for it, like passing by reference, I called it. Obviously, it's an ampersand, right? They call it the address of operator. So my little notes were just ampersand, think address. Memory address. If you just store that in your mind, okay? Every time you see an ampersand, just think memory address of a variable, of an object, of whatever, right? Typically, it's of a variable, right? When things get stored in RAM and on memory, it's stored in memory. It has a memory address. It's kind of like, and the CPU needs to know where to go find it, right? It's a location. It's no different than somebody delivering a pizza to a house. They need to know the address, right? Make sense? Yes, it does. Which returns the address of an object in memory. They call variables or objects in memory as well, I guess. Okay, it's a new take. The way I look at variables, a variable can only hold a certain data type, like a singular data type. So if you create an int variable, it can only handle int data types. Objects can kind of like, I don't know. They do a lot of different things. They call functions. They do a lot of different things. So you could look at a variable like an object, but really, I don't want to go on a tangent, but I always kind of, for myself, I keep a variable separate from an object. Okay? The syntax kind of looks similar, but when you create a variable, you're creating a variable name. But when you have a class, you create an object. It kind of looks the same, but not really. Again, I don't mean to go on a tangent, but an object does a lot more. In my expert opinion, that's if I'm an expert. Yes, it's one of them days. It's one of them days, but it's a good day. All right, we're gonna grind some code out. All right. So again, this course outline, they try to use the different data types. So that's what I find that they do. Where am I typing, Bob? Okay, here we go. Let's create local variables in the main. Okay, we're still understanding pointers. Currently, this is what we're doing. All right, demonstrating the address of operator. Again, this is just like, I don't really need to do this. I could probably just move on, but maybe there's, could be possibly somebody out there that still needs a little extra lecture on it, and that's fine, guys. Okay. All right, so please be patient. Thank you for understanding. If you get it, you get it, right? You could still watch the video, watch the series. It's up to you. Or kind of just scroll the play bar forward or go on to the next video in this series. It's great to have you. It truly is. It's amazing. You're amazing. All right, let's continue. Creating some more variables. So they're using a short, they're using a long. This is going to be called a long var. I see what they're doing though. This is part of the wrapping here, 6.5. I'm going to use this. You can use the single quote as a placement for a comma if you want some separation with your larger, like your 5-digit numbers, right? I like it. So a regular long, I'm just going to kind of use their, this negative? Dun, dun, dun. Well, yeah, it would be signed. Yeah, it's assigned. Okay. Hold up. And I should be able to just copy this. Boom. I don't mean to say lots, guys. Just my brain's thinking here. I want to bring up this, right? You should know your data types. You should understand wrapping and all those things, okay? You should be able to also find that on the internet somewhere. Just search, I don't know, data types, C++, min and max values, data types, C++, something to that effect. I forget where I got that from. Somewhere during my learning. All right, doesn't matter, but hopefully you find something. Or you could actually, I'll just bring it up again. Why don't you just screenshot what I have? I can't really fix that there, or can I? Yeah, no, I could expand it, make it a little bit bigger. Of course, yeah, it looks like I just kind of copied it from maybe a video I was watching. That's okay. All the data types are not there. Again, these are all commas, guys and gals. I know there's decimals there or periods. Just, they're commas. I don't know why it was typed like this. I don't know. Okay? 2.1 billion. All right, negative 2.1 billion to positive 2.15 billion, 0 to 4.3 billion. Okay, and if you have values in your code that are going to be within that range, you would use this. Or if you want this, say you're using smaller values, you could do that. Snipping tool, just snip it. Okay, it's all open source. Technically speaking, if it's been displayed on the internet, it's free for the taking. All right, short var, and we're gonna return. So what? Okay. All right. So okay. All right. So what we're doing now? Okay. First, we're gonna print short var. All right. Colon, and then they're using a tab, \tab. It's a tab operator, so if you want to tab, right, you guys know what a tab is. And then there. And then we're going to return it. Oh, okay, they're doing everything in line. I like that. That works. Okay, cool. Let's do that. I was thinking, do I need to do enters? No, I like the way they type it up. So I'll show you this. No enter. We're just going to tab, again, address. Why can't... What am I typing today, Bob? I can't even spell? Goodness gracious. Learn how to spell Bob of short var. All right, colon. Another \T. We're going to tab again. It's kind of doing everything in line. We're writing everything, 3-lining it. But when it gets returned to the console, there's no enters, right? So everything's going to be tabbed and printed in one singular line. That's what I mean, in line. Okay, remember when we type the and, that means address. We want the address, okay? So if you see ampersand, that's what it means. Yeah, I've got enough of those to clear the buffer. That's good enough. Okay. Talking about these standard end lines I got here. I got one here. Was there another one? Yeah, well, whatever. That's fine. Okay. All right. So that is for short var. So let's just print it so you can see. All right. I'm going to build it. We're just going to do this for short var right now. Okay. We are printing the actual value that's stored, right? We should see 5. And then we're just printing, text just for us to read. That's all it is. It's a string of text, just information for whoever's using their eye molecules to look at it, right? And then after this, we're going to tab again and we're returning the memory address. So this is calling for the memory address. This is calling for the variable. And this is calling, I don't really mean to call it calling, but retrieving. Let's use the word retrieving, right? From memory. All right. Let's print it. Okay, there we go. Short var. Do I need, it looks like I need a space or something after there. What's up? Looks like, so they printed it. There's only a single tab. Looks like we need a double tab. Okay, so I'm going to just, oh, I didn't even put T. That's why. Silly me. I was thinking of putting another one, but I didn't even finish. Okay, there we go. I don't really need to tab here. So I'm just going to go like this because I prefer if it's closer. Kind of do my own editing on the fly. Do I still have that tab? What's going on? Oh, it's right there. Silly me, silly me. And yeah, that should work. Okay, make sure I have a space. All right, let's do that again and run. Okay, now the values are actually right beside. Okay, this is our string literal, right? Okay, string literal right here. String literal. Okay, same thing with this, string literal. And then these are our returns, or the information that's been retrieved from memory. Okay. So we get the value 5, and we also get the memory address. Now guys, if you're doing it at home, I should have maybe explained yesterday, you're not going to have the same numbers, okay? Memory address is just, I don't want to call it random hex, but it's not going to be the same on my PC or as on your PC, okay? I'm trying to get my words out here, but yeah, it's going to be different, all right? Because it's on your own RAM. Okay, my RAM isn't your RAM. Are you connected to the internet on my RAM? Am I connected to through the internet on your RAM? I cannot access that information. Does not compute. Okay, be nice here, but you're gonna have a different number. Okay, if you see a hex format type displayed, you're doing good. Okay, you're doing great. Everything's fine. All right. Apologies, I didn't express that yesterday. Now I don't really need to 3-line this like this. I could go like this, and I'm gonna go like this. I'm gonna paste that, and then I'm gonna go like this. I'm gonna cut this. Make sure you use, there we go. Make sure you use your overloaded O-stream operators, okay? There's another name for it. I've showed it enough times. Watch the video series, find that video, and you'll find it, okay? It has its own name, but I just call it O-stream operator, all right? It's overloaded. So if I build this, it's still gonna run the same. So instead of 3-lining it here in my own code, right, it's still the same return, exact same return, okay? So I did that just to kind of, make it easier for us. Okay, let's do the long var now. Long var, return long var, long var, long var. Easy. And svar. Svar, svar. Do you mind? Did I ask you for your commercial? Did I ask you for your interruption? Did you ask permission to interrupt my live stream? Unbelievable. How rude. Just no respect whatsoever. Okay. Building. Running. There we go. Let's drop the A's. I gotta get rid of this commercial so I can play the music. Normally I don't have commercial interruptions with this particular video, but I don't know, seems like it. Today's one of them days. Exciting. All right. Okay, just moving forward here. So there you go, right? I could have created an enter here so that I got an extra enter, right? If you want an extra enter. I always use double quotes if I'm doing a double enter. And then I'm just going to copy that for the next one. Bop. Hopefully I don't have any syntax errors. We're good, right? There we go. Create some separation. I can literally return it. Exact same thing. That's why you need the first enter is to drop the cursor down to here. And then the second enter creates that extra space, right? And there we go. Again, all your hexadecimal values are going to be not the same. Again, I want to express, if you're seeing hexadecimal code here, you're doing good. Everything's fine. Okay, we're calling for the address, wherever that's stored in memory, by using the ampersand. It's that simple. Okay, 3 variables are declared and initialized. Their values and addresses are printed. The address of operator is used to get the address of the variable. This operator is simply placed on the front of the variable name, right? Yeah, I guess that's right. I always say this a lot, guys. Pay attention to the syntax, right? The position, okay? It's on the left side of the variable, okay? Again, when you grind enough code, you'll know. You'll know where to put stuff. It has to be in, it's like placement specific. All right. You can't just put it wherever you feel like. It's not going to work. So in front of the variable in order to have the address returned. Essentially, that's what it does. Okay. Again, this course outline, they're literally using x86 computers. So it goes to show how kind of old this course outline is. But I figured I'd follow it because theory and everything's all the same for the most part. The syntax and such is a bit different, but I just try to do workarounds. That's what I do. This address is computer specific and might change slightly each time the program is run, right? Yeah, it could, right? So it may change, right? Each time I run it. It may move in memory. You know, we have no control of that. Right? The CPU knows where it is. It's got that pointer, or it creates like a table in memory. It's kind of like its own, it's kind of like it takes its own notes of where things are, right? So it knows where to look. So it creates its own table. All right? That pointer or whatever, the memory pointer or whatever it's called, just something you need to be aware of. You don't need to go full on deep into the understanding of it. You just need to be aware of it. Okay, so it may change or it may not change. Just depends. Again, if you are using an x86 system, these are going to be less, right? Because, well, 64 is 2 times 32. That's all I'm going to say. All right, so when you declare a variable, the compiler determines how much memory to allow based on the variable type. Again, I'm on a 64, so it's going to be 4 bytes. The compiler takes care of allocating memory and automatically assigns an address for it, right? It does all that for you. For a long integer, that is typically 4 bytes. For example, an address to 4 bytes of memory is used, right? And again, that's contiguous memory. What does contiguous memory mean? Think of a train. Woo woo! Rail car, rail car, rail car. One behind the other in a linear fashion. Hopefully you didn't sleep in mathematics class and you know what linear means. Okay? I'm sure you do, because you are beautiful, intelligent, and smart. Okay? All right? I'm saying that in a nice, friendly way. Okay? Nothing. Don't read anything beyond that. Okay? You're awesome. All right. So looking at long here. Is there a long here? 4 bytes. Still 4 bytes. This is all 64, right? You should have an understanding of 32, 64, x64, x86. You should know what that refers to and what it means. It's the architecture, okay, of your system. Storing a variable's address in a pointer. Every variable has an address. Okay? So you create every variable you create gets an address. Okay, that's what was just said. Even without knowing the specific address, because we don't need to know it. The computer puts it wherever it wants in temporary or in RAM. It makes that decision. That's one less thing for us to do. We got enough on our plate already. Okay? You can store a variable's address in a pointer. Okay? And I did that yesterday. Suppose, for example, and again, we're just kind of reviewing, I guess. This is more reassurance for you, and I guess I figure I better follow the course outline a little bit. Suppose, for example, that how old is an integer, right? So I'm going to just get rid of these, okay? And then we'll just run. Okay, so how old? Okay. And what do they have? They have, I don't know. They didn't put a value. Okay. I guess I'll just, where am I typing, Bob? Unbelievable. Okay. I'm just going to put a random number, all right? Initialize and declare. Suppose, for example, the how old is an integer. To declare a pointer called page, you'll see that a lot, right? I could have called it pold. So you could create it here, right? We could create it. It's got to be the same data type. Remember the syntax. So when you're creating a pointer, you first say, I'm creating a pointer. And then typically the syntax will be like P, I could go old. In this case, I could also go PTR, right? I know now it's a pointer. Whatever you want to call it. The P stands for pointer. And then I could go age, right? In this case, you know, typically when you're line coding, things need to be initialized, right? So then in this case, we'll just no pointer it, okay? Because if I don't, it's gonna kind of yell at me and it's gonna recommend it anyways. Okay, so I'm just gonna go like that. So this is how you initialize. Basically it's empty. It's yeah. Okay, we could peek the definition under the hood of a no pointer. The point is it's kind of empty. It's not holding a memory address right now. Remember, this variable is to hold its sole duty. Its sole duty is to store a memory address. That's it. That's its duty. That's its job. Okay? So you can think of it as a memory address type. That's one way of looking at it. Right? It's still an int, right? We still have to kind of match data types here, but this is an int and this is a whole number, which is an integer, right? So we're just matching data types, creating a pointer. Okay, so there we go. That's all we've done. We haven't even said, hey, can you hold the memory address of how old yet? We haven't. All we did was just make it empty. It's just space there. It's allocated space now in memory. It's been created. Okay, so CPU knows where it's going to be placed. Okay, we have to still assign it, right? They have equals 0, but I prefer to use no pointer. Plus, I also like to use whatever the compiler recommends. This declares page to be a pointer to an int. Okay, essentially, right? That is page. I call it pointer age. It's all the same. Theirs looks like the word page, right? Ph. That's the way they typed it. So that's up to you. However you want to create your variable names. Okay, it's still a variable name, right? Even though it's a pointer. So note that page is a variable. When you declare an integer variable, type int, the compiler sets aside enough memory to hold an integer. Okay, which would be 4 bytes. When you declare a pointer variable such as page, the compiler sets aside enough memory to hold an address. Okay, right. Okay, so I gotta kind of back the bus up here, right? So when we create this one, the compiler creates a location in memory, 4 bytes, okay, for this. Okay, it may match or be different with a memory address. I don't know. Okay, let's just find out. On most computers, 4 bytes. Okay, a pointer and thus ph is just a different type of variable. I don't want to. I hope you guys are okay, right? Again, any integer data type is always going to hold, right? That doesn't change. Okay, that logic's the same, always the same. Int is still going to be 4 bytes of memory, right? 4 blocks. Remember, each block is 1 byte, if I recall. Yeah, I'm pretty sure, right? So there's 4 little train cars, little cabooses, okay? For an int, okay? And then I imagine the compiler kind of matches it. I don't know. Let's just move forward, right? The key take here, or the main take, is to know that this is an integer variable and this is a memory address variable. That's really the key take here, that you really... And then for memory, how much memory it allocates, you just need an idea, okay? All right, note that page is a variable. When you declare an integer variable type int, the compiler sets this up. Okay, why am I reading the same stuff again? Pointer, and thus page is... Okay, let's move forward. That's enough talking about that. Pointer names. Pointer names. Because pointers are just another variable, you can use any name that is legal for other variables. Okay, the same naming rules and suggestions apply. Many programmers follow the convention of naming all pointers with an initial P, as in ph or p number, right? Okay, you'll see this. I like to go PTR, so that's kind of up to you, right? And when you look at a variable name, you go, oh, I know what that is, right? Because you could be looking down somebody's code and analyzing somebody's code, right? You could be at line 1000, right? Most of the declaring may be at the top, or it may be close by to wherever you're doing your thing, right? In code. Just depends. Okay? They'll still be local as well. Okay, to the main is what I mean, right? The coloration of my variable, it's blue, which means it's local to the main. If I create one out here, I'm going to go global. I've done this before, but I probably should not. I could go global age, right? Okay, so now you can see the different coloration of my variable, right? So that's a global. I could go gauge, I guess. GL, BL, however you want to do it. I don't know. GBL. And you'll look at your variable and go, yeah, that's a global variable. Okay, a global variable could pretty much be seen anywhere. All right. It is recommended to use local more so. So once you get used to your theme, you'll know. That's what I like about, any IDE is probably going to do the same, right? You'll have coloration for your characters. All right, let's move forward here. Let's continue. Okay, so in this example, we set page or p pointer age to null. Okay, that's how they write their variables in the course outline. Okay, page in their case they initialized it to 0. That's what they did. Apparently, you could do that, right? Myself, I prefer null pointer. A pointer whose value is 0 is called a null pointer. All pointers, when they are created, should be initialized to something, right? So this is the declaration, right? We're declaring. It's no different. Still means the same. We're declaring. And we're initializing. Left-hand side equals right-hand side. Right? The program does not like I don't know what compiler you're using. I guess it could depend on your IDE. So if I create not a pointer, but let's say person's name. Okay, and then I just go like that. The program, you can kind of see it there. There's like 3 dots. Okay, and it has, if you hover over, it'll bring up this little pop-up, and then it'll give you a recommendation or a suggestion. Show potential, right? So basically it's saying, hey, Bob, you gotta initialize it. You can't just leave it be nothing. Okay, I know with regular variables, it would have like, it might even just return the memory address. That's what it looks like. If you actually try to print it, it's not going to print a number. It's going to print garbage, right? If you don't initialize it, okay? It may or may not work. I don't know. Let me just see. I'll test it. Depends on your compiler or the version, the standard you're using. I have to kind of look into that a little more. Right? I don't know why I'm using 20. Don't ask. I'm just sticking to 17 right now, but whatever. It doesn't matter. This is all for learning and teaching purposes only. So if I go like this and I try to print this, let's see what it returns. Okay, it might not even want to return that. Let's see. Let's find out. Might argue. Yeah, uninitialized local variable, right? This is the compiler. It's saying, hey, Bob, you can't do this because you need to initialize stuff, right? Before I could actually print this before. And then you get the C code. A 4-digit code actually has, the 4-digit codes have good suggestions. If you're not sure what this means, again, the more code you grind, the more mistakes. Mistakes are good, guys, because that's how you learn, right? And then you figure it out. And the next time you have that mistake, you're just going to be that much faster at fixing. Okay, you'll become a better debugger, right? So it's saying uninitialized local variable. Yes, it's a local variable. It's telling you the name that you created. Yeah, okay, the variable name that I created, it's called person's name. Yeah, It's uninitialized. So that's the coding lingo, right? You should know what uninitialized means. So I could use 2 curly brackets. That'll go away. Or I could go equals 0. You got to give it something, right? It could even be -1 because we're just using a regular integer. That'll still work, right? What did I do, Bob? Why am I bringing up typecasting? How did I even do that? Okay, all right, amazing. I don't know, I clicked something and then it brought up a web page. I know what casting is, so I'm not worried about it. It's not a big deal. We don't need to cast. We're just doing pointer stuff, right? Okay. Let's get back on track and continue. That's kind of a breakdown on, again, you got to give it something. Oh yeah, I got distracted here. Right, I was going to bring this up, right? A regular int, I could go into the negative. That's why I can use -1. That's amazing! All right. Let's continue. A pointer that is not initialized is called a wild pointer because you have no idea what it is pointing to. And it could be pointing to anything. Wild pointers are very dangerous. You won't have to worry about that scary word dangerous, right? You don't have to go run around your house flailing your arms in the air, screaming like, Walmart temper tantrum baby, acting like your hair's on fire, screaming and crying and bellowing and hollering and tripping and falling on your face and landing on your face and tripping over your shoelaces, and even though you're not wearing shoes, and you're acting all frantic and everything because you heard the word dangerous and it was a big scary word. It's not really that bad. It's not really that bad. Right? Okay. So with that said, all right, just initialize to pointer. Just give it. Put 0 if you want. Don't matter. Then you don't have to worry about that, Okay? So you create a pointer and initialize it. Just any variable that you create, just initialize it. That's it. Bottom line. And you'll be fine, right? You will be fine. And you don't have to worry about that scary word, wild pointers. Practice safe computing. Initialize all of your pointers. Safe coding.
I feel safe now. My pointer is safer.
For a pointer to hold an address, the address must be assigned to it. Okay? Yeah, so you have to assign it still, right? All we did was just make it nothing. For the previous example, you must specifically assign the address of how old to pH, right? It's being specific. Okay, so here we go. So what are they're creating unsigned short ints? Okay. All right, unsigned short ints. They used 50, it doesn't matter. Okay, and then we got our pointer. Okay, that's done. I'm gonna get rid of this. Now we have to assign it, right? And I showed you an example at the end of yesterday's stream. This is what you do, right? You could actually skip this step, right? So basically we're gonna be two-lining this. So, all right, I just need to copy the variable name. We've already told the program compiler that it's an int and it's a pointer. So we don't need to redeclare, right? You'll hear that word redefinition. That's what that means, right? You only need, once you declare something, right? You only need to do it once, like this void function, right? Once you tell the program it's a void function, you don't need to type void in the main again. Okay, I recommend you don't copy and paste, right? Especially when you're talking and you're not thinking and you're just copying stuff and then you're running programs and then yeah. Okay, so now we're going to make it equal to, again, this is all left hand side equals right hand side logic. All right, and we're going to make it equal to, we want it to hold the memory address of this variable. How do you do that? Ampersand equals memory address, variable name, semicolon. Done. That's simple. I'm a slow mod. I do need to speed things up though here. Let's get into another gear. My coffee I'm just enjoying it so much. Every time I play stuff, I take advantage of the coffee. I might need a double size. I might need a 40-ounce cup. 20 is not enough. The first line creates a variable named how old, whose type is an unsigned short int. Did I say short? No, I didn't. Okay, I gotta fix this. Unsigned short. I don't need to actually say int. You can, but you don't need to. So I'm gonna go like this. I have to make it match. Okay, there we go. Yeah, that's, oh, I just fixed my error. I just seen it go away. Right? You have to match the data types, okay? That's all it was. I said that, I mentioned that earlier, right, guys, gals, okay? Again, your program, you could pick whatever data type. If you want decimals, you're going to use float or double, right? It's just that simple. If you need a true or false, you use Boolean or bool. Okay, those are the most common ones. Let's continue. All right. Initialize it with the value 34, which we have. The second line declares pH to be a pointer to a type and initializes it to 0 in their case. We initialized it to null pointer. Imagine maybe it's the same thing. I haven't peeked it. You know that pH is a pointer because of the asterisk. Asterisk! I don't know why I can't say that word. After the variable type and before the variable name. Again, syntax position matters, right? I always put my pointer with the data type. Really, it's, you know, you're going to be fine. I could have it also with the variable. As long as it's in between, that's all that matters, okay? Okay, the third and final lines assigns the address of how old to the pointer age. So now we're, right, that's its job. It's to hold a memory address. This is a memory address now because we're using the ampersand and we're passing that, we're leapfrogging it into the memory address pointer variable, if you want to call it that. If the address of operator had not been used, the value of how old would have been assigned. That might or might not have been a valid address. I don't know. I think it would still break, right? Because we've told the program that this is a pointer, okay? The program knows this as a pointer. It knows that it holds a memory address. I don't think that's going to work. I'm going to have, so if I remove the ampersand, we're going to have break. Yes. Cannot convert from unsigned short to unsigned short. It doesn't make sense logically, but what it's basically hinting to you is saying, hey, Bob, okay, this is a pointer. I'm supposed to hold a memory address. I'm not supposed to hold an integer, right? There's a difference, right, between a memory address and a whole number. Okay? Bye-bye, right? Sometimes the warnings are a little bit vague. You kind of have to think a little bit deeper, right? On the other hand, you could also, if I bring that error back up, click the C code, okay? It'll bring up, you know, your internet web page. It is helpful. Microsoft takes you right to Microsoft, and they'll give you a suggestion if you don't know. And then you'll go, oh, silly me, I forgot my ampersand, right? And then you'll laugh and chuckle at yourself, and then you just carry on. You keep trooping on. That's what you do, okay? You don't go crying to mama and saying, Mama, I need a bowl of cornflakes so I could cry in my cornflakes. It's not that bad, okay? It's little things. Why so serious, Bob? Moving forward, Okay, pointer age is a pointer that now contains the address of the how old variable. Let's go. Getting the value from a variable. Using page, pointer age, you can actually determine the value of how old, which in this case is 50. Well, they used 50. I used 34. It doesn't matter. It's a random number. Accessing the value stored in a variable by using a pointer is called indirection, because you are indirectly accessing the variable by means of the pointer. Okay, try to remember that's a word for the day. Okay, let's call that the word for the day. Some coding lingo. You know, you may or may not hear that in conversation. Okay, between your fellow coding enthusiasts. Right? But you'll have, if you hear the word indirection, you'll have an idea what they mean, right? I try to give you guys the words of the day, the most common lingo that's used when, you know, you're kind of talking code. All right? Understanding the lingo is key. That way you're not staring at somebody with a blank, retarded looking face staring at them, right? Because I don't want that for you. Okay, let's keep going. So again, I'll repeat. Accessing the value stored in a variable by using a pointer is called indirection, because you are indirectly accessing the variable by means of the pointer. So, for example, you can use indirection with the pointer age pointer to access the value in how old. Indirection means accessing the value at the address held by a pointer. The pointer provides an indirect way to get the value held at that address. So what they're basically trying to get to here, guys, what they're trying to get to here, the point is, yes, pointer age holds a memory address, but we could actually access that value that's stored here, right? Because this has its own memory address, right? It has its own location in memory. This is on a dice or a die. If you've been watching my series, you know what I mean. I might even use that analogy, right? So, I like to call a container a shoebox, right? It's a nice little visual for you. You take a dice, you throw it, has the number 34 on it, you throw it inside the shoebox, there you go. The shoebox has a memory address on the side of it somewhere so that the CPU can roll up to it and go, oh, here's the address, and then it grabs the dice that's inside of the shoebox or the container and it uses it, right? This guy, this is another person kind of down the street, and he's pointing at this. He's pointing here. He's pointing here. He's going, hey, over there is the address, right? Even though he's off in a distance, he can still access that value that's stored inside. So he actually can retrieve that dice, if you will, right? He's got pretty long arms when he's pointing, apparently. It's all just jokes, but it's kind of like gives you kind of an analogy here, right? This guy's pointing. He's standing in the middle of the street and he's pointing. That's where it is. And he can actually, he or she, doesn't matter, right? This is all hypotheticals here. Can access that die out of the shoebox, grab it and go, okay, now I got the number, right? So how do we do that? How do we do that through code? Let's do that. Let's get to it. When a normal variable, let me start again. With a normal variable, The type tells the compiler how much memory is needed to hold the value. In this case, 4 bytes, right? For the container, I guess the shoebox is the size of 4 bytes, right? If you think of it. Okay, thinking a little bit deeper, right? And then there's like 4 bytes, so there's technically speaking 4 little mini containers inside that shoebox, if you think of it like that, right? Because each container is 1 byte. So technically speaking, there's going to be 4 containers inside that shoebox. All right, this is kind of my analytical approach to it to help you guys understand. All right? Right? Because a shoebox, you could put 4 little mini boxes inside of it. Could you not? Each little mini box is 1 byte. With a pointer, the type does not do this. All pointers are the same size, usually 4 bytes. There we go. Now there's our answer because I was not 100% sure about that. Now we know. So they say usually 4 bytes. So a pointer is usually 4 bytes. Okay, because hexadecimal is kind of like I'm going on a tangent a little bit, but you have IPv4 addresses and you have IPv6 addresses. They're not the same, right? IPv6 is like more bits and bytes. I'm just going to leave it at that, but let's keep moving forward. Okay, don't mean to go on a side note here. Usually 4 bytes on a machine with a 32-bit processor. Oh, okay, here we go. So on a 32, they're saying that a pointer is usually 4 bytes on a 32-bit processor, okay? And 8 bytes on a 64-bit processor, right? Because it's double. 32 times 2 is what? 64, right? So x64 is twice the size of 32. I know it's redundant to say that. It's obvious, right? We all know this. Okay. People are using x86s nowadays? I don't know. All right, the type tells the compiler how much memory is needed for the object at the address which the pointer holds. In the declaration, unsigned short int, pointer ph equals 0, make a pointer. Ph is declared to be a pointer to an unsigned short integer. Okay, I don't know, I feel like we're just repeating all the same stuff. This tells the compiler that the pointer, which needs 4 bytes to hold an address, will hold the address of an object of type unsigned short int, which itself requires 2 bytes. All right, so on the 32, take note, guys, okay? In case you don't know, I'll just bring this up. These values here are for an x64, okay? x64 architecture, x64 system, x64 CPU. On an x32, it's half as much. Now, I don't know. I think it's the same for chars. I'd have to look into it. Okay? So it's half as much. Okay? Remember, don't sleep in fractions class, guys and gals. If you see a /, that refers to division. What does division mean? A fraction. Let's go. I say that because you should solve all your problems not in a linear fashion, but solve all mathematical problems in a fractional fashion. That's why I always say don't sleep in fractions class, kids. All right? Like, can you read a measuring tape? Not a metric one, okay? I could get my cat to read a metric tape. All right, let's carry on. More coffee, nurse. time flies when you're having fun. I really need to stop talking so much. All right, I need to talk, to teach. Okay, let's continue. Dereferencing. Okay, this is where we're getting into it. Okay, dereferencing. Dereferencing. Okay, I showed the example yesterday. If you guys already get it from yesterday's stream and you understand, we're kind of going over it a little bit again, I guess. This is more reassurance, more instruction on pointers, if you will. I showed you dereferencing in the passing by pointer reference example. Okay, so we are going to do it still. Dereferencing, why can't I say that word? With the indirection operator. That's what they call it. They call it the indirection operator. Okay? In my example yesterday, passing by pointer reference, when we type the asterisk here, this means pointer. Okay? To start off on that note. Ampersand means memory address. Okay? So basically, we turn this variable into a memory address. Essentially, that's what we're doing, okay? When we add the ampersand. It's like switching. Remember when I was talking about the exclamation point knots? It's kind of like that. We're switching. We're switching it from a variable that holds a whole number to a variable that holds a memory address. Essentially, but again, the right side is just temporary, floating in limbo stuff, right? Remember that. Okay, it doesn't have a memory address. The right hand side doesn't have a memory address. It's just floating in limbo information. And we have to pass it to the left hand side. Okay, that's the idea and concept of left hand side equals right hand side logic. It seems simple enough. I know if you guys done enough math and you didn't sleep in math, you understand what equals means, right? But we're doing computer science stuff here, right? All right. So the indirection operator, which happens to be another, this is where why people get when their brain breaks. Okay? Don't let your brain break, guys. It's not really that big of a deal. All we're doing is we're using the same character to do a different task. Okay? Right? If I go like this, okay? And I'm a bird, okay? I'm a bird in the sky. Okay, I'm a bird in the sky, and I see all of this, and I'm looking at the top of people's heads. Is that not an individual? Is that not an individual? Is that an individual? This is a different individual. Oh wow, that's another individual. Oh look, that's a different individual. Oh, that's another individual. All of these individuals are different individuals. Isn't that crazy? That's wild. So this individual is doing a task, and this individual is doing another task. It's crazy how other people could do different tasks and not the same thing. It's wild, man. That's wild. I say that with the utmost love, guys and gals. I say that with the utmost love, right? Just to help people understand, right? Yes, we're using the same character. Yes, I know, we're using the same character. Your brain doesn't need to break because we're using the same character. It's just another individual doing another different task. That's why I said all that, right? So it's its own thing doing its own individual task. its own function. It serves its own purpose. It's doing a different thing. Isn't that amazing? How things could do different things. So let's continue. The indirection operator in front of the pointer variable P pointer age means the value stored at. Yeah. I don't know if I like reading their analogy because I think my analogy helps. So it's called dereferencing. Dereferencing, okay? Like my example yesterday. I don't even know if I want to read their analogy because I don't want you guys to get confused, right? Passing by pointer reference. My example yesterday clearly explains, right? So inside our parameter, we have, okay, I don't have the example in front of me, but so this one here is pointing. It's the pointer. It's the dude on the street pointing, going, hey, it's over there, Bob. Okay, that's a different dude. This is a different dude. Okay, this is a new dude. It's another dude. Okay, so what we do is we put the pointer in front of the variable to dereference it. That's why you'll see the other symbol. Okay, it's just another task. All right. So what I could do actually, just so you can see that in code, why do I capitalize first? And I do apologize, guys, if I come across like, I'm just trying to help y'all understand. I'm not treating you like you're stupid or anything, okay? Please don't think of it like that. Okay? It's, I don't know, I guess, a guy's just tired of eating bolognas and wieners and doing all this, and it feels like it's all for nothing, but I keep getting up, I keep troopering on, and I still keep going. Okay, I want you guys to learn, right? So here, I'm just going to print this. Okay, watch. Okay. So this first line, right? Remember, this is holding a memory address right now, right? Holding a memory address right now. Right? That's what it's doing. Okay? Right here, this guy. It's the exact same thing. This guy is this guy. Okay? Its job, a pointer, right? Remember? All right? Its job is to hold a memory address. That's its duty. To store and hold a memory address. Here, this line, I'm going to be printing the memory address. Because that's what it's doing right now. Okay? Because it's storing it. That's what it's holding. That's the information it's holding in memory. It even has its own memory address. I know, I don't want to break your brain, but it does, right? It needs a location in memory too, right? It needs to have its own house. Can it not have its own house too? Unbelievable. Anyways, let's carry on. All right? So the dereferencing, referencing. Okay, that's what we're doing here. That's what this is doing. I'm going to get rid of this. Okay? Actually, well, it's all the same, right? I should have went like this. I'll just put it right above. Okay? So I wrote it there just so we could print it, right? So this here, its task is to basically transition the memory address to the value that's stored at that location. So remember, it's pointing here. It's pointing here. It's saying, this guy here, this guy here that we created is pointing here, right? It's pointing and saying the address is over there. And it'll hold that address. Okay, I had a thought, but I don't know. We'll just kind of, I hope that's helping. I feel like maybe I don't know. I'm sorry, guys. I do apologize, but I want you guys to get this because a lot of people just don't get it, right? And it's not even that hard, in all honesty, right? I'm trying to help here. Don't forget to buy me a coffee if I actually help you, okay? Again, you know, my time is my time. I could just be doing this stuff by myself, creating programs, just doing whatevers. I could just do my own thing in my own house, in my own address. I don't have to share. I don't have to help. I don't have to do any of this. But, for those that are actually watching and learning along, you guys keep me going. And I love you guys. I do. Those of you that are watching, right? You're still watching, right? I appreciate you, okay? I really, truly do. And you keep me motivated too. I enjoy the teaching. Okay, I could probably come across a little bit better, but I'm trying, right? Trust me, this is still nice. Okay? This is still nice. All right? But I want you to get it, right? Because I want you to actually learn. All right, so to keep things simple, again, here we're going to actually print the address because it's holding the address. Here, we're dereferencing it, and basically, this is the point where you're actually reaching and grabbing the dice from this guy, right? This is the point where he's pointing, but then now all of a sudden he's reaching to grab that value from the container here. Okay, that's what it's doing. That makes sense? I hope so. You can kind of get that, right? First he's pointing, then he's storing, right, in memory, because now he knows the address because he's pointing to it, right? Now he knows the address. Okay, so now we're going to just print the address because really from his memory, it's no different than me writing it down on a piece of paper and saying, hey, this is the address, right? And then here we have to, like, we're just kind of grabbing it, right? That's what this job of this indirection operator is, to grab that value. And it's grabbing it from here. It's grabbing it from here, guys. Okay, it's reaching across the street with his long arms and grabbing it. That's what he's doing. Okay, no fancy visuals. I hope that's a visual. Right, so imagine that. Let's print and run. Okay, I've got it all in the wrong spot here. Hold up. Why am I printing there? Hang on, guys. I'm not even in the right spot here. Hold up. Okay, here we go. Okay, there. Let's get inside. Up here is where I do all my declaration of my local variables. And I like printing inside my scope. Silly me. I can still sleep at night too. All right, let's do it again. Let's run it. All right. And there we go. Drop the yays. Let's drop the yays. Drop the yays. And I'm going to add a couple of spaces there just so you can see, have some separation. Okay. I'm going to go like that so you can see all the code. All right, there we go. All right, so look, guys, gals, isn't that easy? It's not even that, it's not that, right? You guys get it, right? You guys get it? You totally get it. I know you got this. You get this. It's really that simple, isn't it? Isn't it? It's pretty simple. It really is. It's that simple. Right? Check it out here. Right? Here we're printing the address. And here we're dereferencing. We're grabbing that number, right? Just pretend this guy here now, he's grabbing the number. Right there's the number. Look. We grabbed it right from here. We said, hey, thanks. Okay? Don't worry, he's not being a criminal or a thief. He doesn't actually have the value, but I don't know, somehow he knows the number now. Okay? This guy's still holding that value. We can actually change that value through this guy. We can actually change it, right? Because that's what passing by pointer and passing by pointer reference does as well. You can modify values, guys and gals, right? This is above. This is advanced kind of coding. I don't want to. Is it advanced coding? It kind of is. I mean, it's difficult for a lot of people. That's probably why they're not watching and why there's not many views, because they're off doing Python code. I know I'm hilarious. I am. All right. Where shall we go now? How much time are we in? It feels like I'm just into this for too long here. I hope that helps huge. I hope it did. Yeah. A pointer provides indirect access to the value of the variable whose address it stores. To assign the value and how old the new variable. Okay, I don't want to, honestly, I think, right, I don't really want to kind of reread, because I had my own take and to help you guys learn, right? It may not have been the best take, but I bet you, I guarantee you got it. I'll guarantee you got it. Right? Right? It may seem like tough love, but it's still love. Okay? The love is still there, guys, gals. The love is still there. All right? Persevere, stand up, chin up. Okay? You're strong. Wiser, better, faster, stronger. Take the value stored at the address, blah, blah, blah. I think I'm going to move forward from that. Okay? Pointers, addresses, and variables. It is important to distinguish between a pointer, the address that the pointer holds, and the value at the address held by the pointer. And that's kind of what I just went over, right? It's important to distinguish between. It may not have been the most nicest approach, but I definitely feel it got the point across. No pun intended. I think we're going to move forward from now. I'm going to kind of skip all this, right? Because I don't want to overanalyze, over-explain, which I've already, right? I'm kind of skipping through the course outline a little bit. Manipulating data by using pointers, right? So now that's the next step. Now that you've got the understanding, right? Now it's utilizing it in code. Once you get it, man, you just it's like, I don't know, like the world's your oyster, like I say. Right? As soon as you get it, and you be kind of chuckling at the people that don't get it, because now you're even man, that, how simple is that? That's pretty simple. It's not even that difficult to understand, right? You're next level. Okay. So yeah, that's what we're gonna do next. It may have been a couple of videos on that, but again, it's one of those areas that's, a hurdle for most. Not for you, right? As the saying goes. as the saying goes, when they say it's impossible for them, not for you. And again, losers quit when they fail. You guys, being the winners fail until they succeed. Let's go. Yeah, that's my motivation. I appreciate you guys and gals. Remember, I love you, every single one of you, whoever you are, wherever you are. Thank you for watching. You're all legends, every single one of you. We are going to get into manipulating data by using pointers. We're going to actually utilize it in code, right? And see the changes and see all the magic happen. So stay tuned next stream. I know this is probably, I don't know the length of them or the length of them. I can't control. Time flies when you're having fun. I am having fun. I'm enjoying helping you guys learn and teach. Again, remember, sharing is caring. Sharing is caring, right? Your support is great. Every single one of you hitting the follow and the like or whatever. It's amazing. You guys are amazing. Thank you for that. Help the channel grow. Bologna&Weiners coding. Appreciates you. My name's Johnny. And help the channel grow from Bologna&Weiners to Beef Wellington. And then we're all going to be playing golf together because I can't wait to hang out with every single one of you beautiful, intelligent people and just play some golf for fun. Let's go. That is it, guys and gals. I'm bouncing. So you have a great rest of your day, whoever you are, wherever you are. You're all amazing again. Don't forget to look at yourself in the mirror and say, I am awesome, because Johnny said I am. And it's true. In fact, it's true. That is it. I'm going to Shaddy Eddie. You guys take care, and I'll see you in the next live stream. Take care for now, and peace!
Baby, I don't understand this.